ठीक है ना ऐसे
हाँ सर.
Okay, so today in this meeting, we are going to do the topic application of integrals, that means areas. We are going to do this topic today. Now, in this topic, first thing that you need to know is that whenever you have a graph y equal to fx, like y is a function of x, so the area below the graph above the x-axis and between these two verticals x equal to a and x equal to b. So the area below the graph above the x-axis and between these two verticals x equal to a, x equal to b, this area is integral a to b y dx, right? So area below the graph above the x-axis between x equal to b is integral a to b y dx. Now suppose the graph itself is intersecting the x-axis at these 2 points a and b. Like here you can see this graph is not intersecting the x-axis at all, but suppose the graph is intersecting the x-axis at these 2 points a and b like this, then also the formula will be integral a to b y dx. So if the graph is not intersecting the x-axis, then also a to b y dx. If it is intersecting the x-axis, then also a to b y dx. Similarly, suppose Similarly, suppose you have a graph like this. Okay, this is the graph, and there is a point on the y-axis P, there is a point Q, and you want the area to the right of this y-axis. Okay, you want the area to the right of the y-axis and between these two horizontals P and Q. So then the answer will be integral P to Q x dy. So integral P to Q x dy is the area to the right of the y-axis between the horizontals P and Q. And if the graph is intersecting the y-axis at two places like this, then also this formula is applicable. So this is the basic formula of finding the area by integration. Integral a to b y dx is for the x-axis and p to q x dy is for the y-axis. Okay, then we come to non-standard areas. So there's a graph, this one fx, and this is the one below is phi x, and the 2 points are a and b. So integral a to b fx minus phi x dx, this will be the answer of this integration. Okay, so fx is the above one, phi x is the below one, and integral a to b fx minus phi x dx will be the required answer for this one. Okay, now suppose you have two graphs, one is fx and one is phi x, and they are both meeting each other over here. This is A, this intercept is A, this is B, and this point is suppose lambda. And let's say we want to find the area under this graph. So we want to find the area under this graph. So the area will be you integrate from a to lambda fx dx, and then you integrate from lambda to b phi x dx. So integral a to lambda fx plus lambda to b phi x, this will be the answer. Okay, now the thing is that in this particular chapter, you will not get any extra marks for drawing the graph, okay? But there are some standard graphs which you should be aware of. You will not get any, you have to find the area under the curve, but there is no need to actually draw the curve. You can do the area as an integral and get the answer, okay? But some graphs are very basic and you should know it, the very, very basic ones. So, like basic ones for this topic for integration. So obviously the first one is the straight line graph x by a plus y by b equal to 1. Then x square plus y square equal to a square. Then y square equal to 4ax and y square equal to minus 4ax. Then x square equal to 4ay will open up and x square equal to minus 4ay will open down. Then the ellipse x square by a square plus y square by b square equal to 1. Then the hyperbola x square by a square minus y square by b square equal to 1. Then the rectangular hyperbola xy equal to c square. Then this graph of sin x and cos x. Then tan x. Then cot x. Then log x. Suppose there is a graph in which there is a function rather in which you only have even powers of x. So it will be symmetrical about the y-axis like this. And suppose you have a graph in which you have only got even powers of y. So even powers of x will be symmetrical about the y-axis and even powers of y will be symmetrical about the x-axis. Okay, if in a graph you have y equal to 0, then y equal to 0 will give the x-intercept, or you can say that x tends to infinity. X equal to 0 will give the y-intercept, or y tends to infinity. So x tends to infinity means the graph will look like this, and y tends to infinity means the graph may look like this. So if you put y equal to 0, either you will get the x-intercept, or you may get x tends to infinity. That means the graph will touch the x-axis at infinity. Similarly, if you put x equal to 0, either you will get the y-intercept, or you will get y tends to infinity. This is a graph which is positive for all x between a and b, and you have a graph which is negative for all x between a and b. If you have an increasing graph, then y dash is positive. If you have a decreasing graph, y dash is negative. So that means what? For drawing graph, one is to the basic graphs, you'll have to remember them. That is the first thing. The second thing is that you will have to know that even powers of x are there. That means it is symmetrical about y-axis. And even powers of y are there, that means it is symmetrical about the x-axis. If you put y equal to 0, either you will get the x-intercept or x will tend to infinity. If you put x equal to 0, either you will get the y-intercept or y tends to infinity. And if you are always getting y positive, then x is between a and b and y dash is positive. If you are getting y negative, between x, a and b and y dash is negative. So these are the things. Okay, now suppose you have a graph, sketch y square into a square plus x square, a is equal to x square into a square minus x square. So suppose you are asked to sketch this graph. So the first point it is symmetrical about both x and y axis. Second point is that if y is 0, then x is either 0a or minus a, and if x is 0, then y is 0. If x is greater than a or less than minus a, then y square is negative, which is not possible. So the question is that you have to sketch this graph. So it is symmetrical about both x and y axis. When y is 0, x is either 0 or a or minus a. If you put x equal to 0, then y is 0. If x is greater than or less than minus a, then y square is negative, which is not possible. So this is the graph and this is how it will look. So at a, minus a and 0, y is 0, and beyond a and beyond minus a there is no graph. So this is a general technique, you can say, for drawing graphs. Then we come to the next question. Find the area between y equal to sin inverse x and y equal to plus minus pi by 2. That is a question. So this is how the graph will look. So twice 0 to pi by 2 x dy. So twice 0 to pi by 2 sin y dy. So that is equal to 2. So find the area between y equal to sin inverse x, y equal to plus pi by 2 and y equal to minus pi by 2. So you draw the graph, this minus pi by 2, this plus pi by 2. So the area will be double of 0 to pi by 2 x dy. That means double of 0 to pi by 2 sin y dy, and that is coming to 2. So in this question it was better to use the formula x dy. Question number 2, find the area bounded by y equal to x into x minus 1 into x minus 2. So this is how the graph will look. So this integral will give you the area from 0 to 1. and this integral will give the area from 1 to 2. Okay, now this integration, after you do it and put the limit 0 and 1, so you will get 1 by 4. But this area you can see it is below the x-axis. So when you put the limit, you will get 0 minus 1 by 4. So that is why we have put a mod, because you know that like in coordinate geometry, in this chapter also, there is a chance that area may come negative. So you have to put a mod. So if you put a mod, then inside the mod it is 0 minus 1 by 4, so the total thing is coming to half. Okay, the next question, the graph of y equal to 2x minus x square, and there is another graph y equal to minus x. So this point is x equal to 1 and this point is x equal to 3, and this point is x equal to 2. So twice 0 to 1, 2x minus x square, that will give you this area. Then next you take 0 to 3 of the straight line, that is minus x dx, but you take mod because it will be negative, and then you subtract the parabola from 2 to 3. So parabola from 2 to 3 means this one. So this plus this minus this. So this integral works out to 4 by 3. This integral after limit works out to modulus minus 9 by 2, and this one works out to modulus minus 4 by 3. So after simplification, the answer is 9 by 2. And in fact, that is the final answer of this particular question. So we have basically done all the types of sums. We have done sums based on x dy, the first sum. We have done sums based on y dx, second sum. And we have done non-standard areas, means two intersecting graphs, how to find the answer. And we have discussed different types of graphs, how to sketch a curve from scratch. And always remember, there is a issue of negative areas, so you have to take a modulus, right? So on that note, I'll conclude this session and we'll wind up for today. Thanks a lot. Bye all of you.